Friends, welcome to my YouTube channel. Dhanesh here. So in this video, I am going to discuss the complete mathematics of gradient descent algorithm and cost function. See, gradient descent is an important algorithm we use in machine learning, artificial neural networks, deep learning, many places we use. Gradient descent, it's an algorithm even we use in economics and statistics. So what exactly is gradient descent? Gradient descent is an iterative optimization algorithm used to find out the minimum of a function. So gradient descent is an iterative optimization algorithm used to find out the minimum of a function. We used to find out the minimum of a function. This is gradient descent. See, let's start. See, for example, we have a function like f of x. We have f of x is equal to x cube minus 3x square plus 1. If you plot this function in a graph, you can get it like somewhat like this. See, I am explaining the mathematical concepts behind this gradient descent algorithm. If you plot it, it will be somewhat like this. This is 0, this is 1, and this is 2. See, from this plot, from this graph, the function x cube minus 3x square plus 1 is having a global it's having a maximum. You can tell it as this is the maximum, and this is the minimum. Since this maximum is at x is equal to 0, at x is equal to 0, you are having a maximum value, and at x is equal to 2, you have a minimum value. This is the, when you plot it, you can understand it. But the same thing, you can get it by using the calculus approach. So I can tell you how do you find out the maximum and minimum by using the calculus approach. See, you can see here fx is this. So what would be f dash x? F dash x will be equal to the derivative of this function 3x squared minus 3 into 2x, that is 6x plus 0. We are using the formula derivative of x raised to n is nx raised to n minus 1. That's all. So you got it as 3x square minus 6x. Then we will take f dash x equal to 0. Then you can write it as 3x square minus 6x equal to 0. Then you can write it as 3x into x minus 2 is equal to 0. When you solve this, you will get x is equal to 0 and x is equal to 2. From the plot as well, you got it. X is equal to 0 is the maximum of the function, and x is equal to 2 is the minimum of the function. So this is the way of calculus approach. You know, here we have maximum and minimum, but which one is maximum and which one is minimum, you need to do the second derivative test. I am not getting into that. See, you will find out f double dash x. The test is this. You will find out the second derivative of this f double dash x, and if f double dash of 0 instead of x, you will put this value 0. If that is a positive value, it's a minimum. And if it is a negative value, it's a maximum. This is the second derivative test. Okay, anyway, I am not getting into those details. But why can't we use this calculus approach? Why we are going for this gradient descent algorithm to find out the minimum of the function? The reason behind that is, if your function is very complex, for example, you have a function like f of x is equal to e raised to x tan x into log x divided by x raised to sec x. This is your function. You can find out the derivative f dash x. It's fine. That's also a little bit complex, but the most complex process will be the solving of f dash x equal to 0. You will assume f dash x is equal to 0 and you need to solve for x from this equation. That is a very tedious process. So that's why we cannot use calculus approach everywhere. So that's why we are getting into the gradient descent algorithm. So what exactly we are doing in gradient descent algorithm? So in gradient descent algorithm, for example, if you have a function, I am telling if you have the function, this is your function, x is equal to 5x square minus 6x plus 7. So what value of x? The function is minimum. We are more interested into the minimum, that we call it as the global minimum. That algorithm we will call it as the gradient descent. If you are more interested into the maximum value, we call it as gradient ascent. We are not discussing gradient ascent here. We are discussing gradient descent. So what you will what is the value of x for this? So in this iterative approach, what we will do is, let us assume a random value for x for which this f dash x is 0. We are assuming a random value for x. This is x. We are assuming a random value x for which f dash x is equal to 0. Then we will, if f dash x is not 0, so we assume a random value and we calculated f dash x. At that time f dash x is not 0. Then we understood this random value is not the minimum. Then again we will, this f dash x is greater than 0. Then we will again optimize x. We have to again decrease the value of x. Like that, we need to optimize it. We need to repeat this. So that's why we call it as gradient descent is an iterative optimization algorithm to find out the minimum of the function. So in that way, when you iterate it, you can come up with an equation like this. See, we will keep on changing the value of x. So x of I plus 1 is equal to xi plus or minus alpha into f dash of xi. This is the algorithm. So this is the equation you will get it. X of I plus 1. So you will calculate, you will take a random value for x, you will find out the derivative of, you will calculate f dash x and you will substitute the value. At that time, if it is not 0, again we will, change the value of x and we will come up with this. Here, what is alpha? Alpha, we call it as the learning rate. Alpha is known as the learning rate. Its value is between 0 and 1. Its maximum value is 1. The maximum value of learning rate is 1 and its minimum value is 0. So what is learning rate? The size of the steps to be taken to reach the global minimum. That is learning rate. The size of the steps to be taken to reach the global minimum. So this is all about gradient descent algorithm. So now I am getting into our cost function. How we can use this gradient descent algorithm to find out the minimum of the cost function. See, cost function denotes error of a machine learning model. You know it. Cost function is equal to error. That means it is the predicted value minus actual value or target value. It is, you can write it as predicted, the predicted value of the machine learning model minus actual value. Actual value, you call it as target value as well. So this is cost function. So there are different type of equations for a cost function. You can call it as mean squared error, mean absolute error, then root mean square error, or even squared error. All these things. See, why we are coming up with the mean squared error, mean absolute error. See, the reason is when you calculate the error of each data point and when you sum it, the error can be positive or negative. This predicted value is less than the actual value, it can be negative. If it is greater than the actual value, it can be positive. So in the same way, this when you add positive and negative, you can get a different answer. You won't get the correct answer. When you square it, everything becomes positive and you will get a proper value. So that's the reason we go for mean squared error, root mean squared error, mean absolute error, squared error, all these things. So here in this video, I am going to use the squared error everywhere. So you can use any one, it's not a problem. So I am using squared error. If you're using mean squared error, means 1 by you divided with the number of data points, that's all. So I am using the squared error here. So this is what we are going to do. So I can write the cost function as cost function, the formula I am writing it as cost function is equal to sigma I is equal to 1 to n y dash minus y the whole square. See, this y dash is the predicted value, y is the actual value. So this is our, see, when you, this is the squared error. When you go for the mean squared error, you will divide it with 1 by n as well. So I am not using here, you can use 1 by n as well. That's not a problem. So now, again, I can write it as it's equal to this y dash minus y is the error. So the cost function it is denoted by the letter j. So j I can write it as j can be written as j is equal to sigma I is equal to 1 to n error square, because y dash minus y is the error and this is error square. So this is the equation. So this is all about cost function. So from the, and one more thing I want to tell you, this cost function depends on two parameters. One is the weight and another one is the bias. Cost function depends on weight and bias. See, what is weight and bias? The simplest explanation I can give you, the model y is equal to mx plus c. Here m is the weight and c is the bias. So this is the simplest explanation I can give you. And the weight and bias, see, the cost function can be changed, can be optimized by varying the weight and bias of the network. So the reason is, when you plot a model, see, you have the data points and you are coming, so these are all your data points, you have many data points like this, and you are coming up with a model like this for this. So here this theta and tan theta is the weight, that is m, and here if your model is like this, this is your C, y-intercept, that we call it as the C. This is C. This is your C. See, by varying this theta and C, you can change the model. When you vary the theta, the model can be like this. It can be like this. The model can be like this, or it can be like this. So you can find out the best fit model by varying theta and even by varying the y-intercept as well. So you can, when the y-intercept is like this, the model will be like this. When you change the y-intercept to 0, your model will be the green line like this. And even you can have negative y-intercept. At that time, your model will be like this. So you can change the value of M and C. M means tan theta. When you change theta, tan theta will be changed. So in this equation, y is equal to mx plus c. By changing M and C, that is the weight and the bias. M is the weight and C is the bias. By changing weight and bias, you can come up with the best fit machine learning model. So that is known as, the optimization. So the cost function, the error depends on, we can tell the cost function depends on the weight and bias, because when you minimize the error, the cost function is also changing. So the important point you can tell it from here is the cost function J depends on two attributes. One is the weight W and the bias B, two parameters. So bias shift the model left or right. Weight changes. The model becomes, when you change the weight, the model becomes more and more steeper. That's the point. So anyway, the cost function depends on the weight and the bias. So what we understood is, to minimize the cost function, we need to work on these two attributes. One is the weight of the network and another one is the bias of the network, or bias of the model. For an artificial neural network, it is like that. Or, for a machine learning model, we need to work on the weight and bias. So the previously written equation can be changed. It is, instead of x, we can come up with the new equation. That is, you can write it as, for weight, I can write it as a W. I plus 1 can be Wi minus alpha into dou J by dou W. Because that is f dash. See why I am using dou, it is the partial derivative. When we use partial derivative, when your function depends on multiple variables, you will go for partial derivative, because our cost function now depends on two variables. One is weight and bias. So that's why I am using dou. In the same way, I can write it as B of I plus 1 is equal to Bi minus alpha into dou J by dou B. These two equations. For a cost function, for a machine learning model, the gradient descent algorithm is modified in this way. This is our equation. Now I am going to find out what is this dou J by dou W and what is dou J by dou B. So we have, our error. It is, I have written previously, it. J is equal to, you have J is equal to sigma I is equal to 1 to n error square. This is our cost function. So dou J by dou M should be, when you take the derivative of x raised to n x raised to n minus 1, 2 into error into dou by, the weight we have taken as W, dou J by dou W. So dou by dou W of error. This is the derivative. Dou by dou W of error. In the same way, you can calculate dou J by dou B. It is equal to 2 into error into dou by dou B of error. So you will get these two equations, dou J by dou W and dou J by dou B. So 2 into error into dou by dou M of dou by dou W of error and dou by dou M dou B of error. So what is this dou by dou W of error? So I am going to calculate dou by dou W of error. See, error is dou by dou W of y dash minus y. What is y dash? Dou by dou W of y dash is, y is mx plus b. Mx plus b minus y. So when you differentiate, see here we need to take wx. Our equation is w because we have taken the weight as dou by dou w. So our equation is wx plus b. So dou by dou w of wx plus b, when you take the derivative of with respect to w, all these things are constants. This is constant, this is constant, everything is constant. So you will get only the variable as w. So here x is also a constant. So what is dou by dou w of wx? It is, the answer is x. That is dou by dou w of error, with respect to when you differentiate with respect to w. So this is x, because here the variable is w. Normally everywhere we use x, here x is a constant. You need to understand. Here the variable is w. So dou by dou w of error is x. In the same way, I am calculating dou by dou b of error. So it is dou by dou b of error should be is equal to, again, dou by dou b of y dash minus y. That is dou by dou b of, what is y dash? w. Here we have taken as w. Here it is w ix plus b minus y. Here, which is the variable? Here only b. All other w, x, y, everything is constant. So b is the variable. What is the derivative of b? With respect to b, it is 1. So here you will get the derivative as 1. So your equation will be again modified as, you can write it as your first equation. The first equation is m of I plus 1 is equal to mi minus alpha into dou j by dou w. So this was your first equation. You got it from gradient descent. It is w. We have taken weight as w. So we can write it as w of I plus 1 is equal to wi minus alpha into dou j by dou w. So this one you can write it as a w of I plus 1 is equal to wi minus alpha into, what is dou j by dou w? We got it as 2 into error into x. So you can write it as 2 into error into x. So this is the, when you take the mean squared error, 2 by n will come here, that's all. So 2 into error into x. In the same way, you have the equation b of I plus 1. So you have b of I plus 1 is equal to bi minus alpha into dou j by dou b. This one you can write it as b of I plus 1 is equal to bi minus alpha into 2 by n into error. So this is there, error into x was there. Here error into 1, what you got is 1. It is so error. So this is the two sets of equations you will get. So the corresponding equation, this is the most important equation, error. So this is the equation. So previously you got it for w as well, weight and bias, how you can optimize it. So based on these two equations only, you optimize the cost function by using gradient descent algorithm. Here alpha is known as the learning rate. So that's all about the mathematics of gradient descent algorithm. Thanks for watching.